Okay, one more time. One more time with feeling. I can't get the dimensions right on this. But, alright, so in class, when I did the linear probing example for the final exam, I made an error. I did not resize the table correctly. So I'm going to show you how to do it correctly. I've deleted, or at least it's in the process of being deleted, that portion of the video from the lecture. So this will be the correct version. I'm also going to give you a little bit of extra insight into exactly what you'll see on the exam. So in class we did this, and then there's also a second example where we remove some elements. On the final you will see something like this. This add 47 will be some remove statement, 39, and then we will add something afterwards. Okay, so let's go over exactly how to do this correctly. The first one is done for you. There are our table size is 2. There are 2 locations. Half of them are null, so that's good. So the criteria, of course, when I was thinking of resizing, I was thinking back to most of the data structures that we looked at, which is resize when full, double the size. Of course, linear probing is different. We do not resize when full. We resize long before that because we want at least half of our locations to be null. So anytime the number of null locations drops below half of the available locations in the table, we have to resize. Or when it's about to when we're about to have less than half the null characters. All right, so in this example now we're going to add 63. If I added 63, there would be 0 null characters left. So I have to resize at this point. So I'm going to double the size. Okay. Now before I add 63 though, I need to copy everything from my old array to my new array, and to do that I'm going to rehash this value 39 mod the size of the table, which is 4, and that's going to give me a value of 3. So I'm going to add 39 to location 3. And then we can add 63, so 63 mod 4 is also 3, surprise, surprise. So I'm going to try and add 63 here. I see that there's already a value in that location, so I'm going to move right to the next available location, and if I run off the end of the array, I'm going to go back to the beginning. I'm going to wrap around. So 63 will actually get added here. This is the next available location, and then the other 2 locations are null. All right, so I have a table. It's half full of null characters. Everything's good at this point. Okay, so now when I add 15, well, we can see that regardless of where I end up putting 15, I'm going to lose one of my null characters, and now I will only have 1, and that is less than half. That is not enough, so I actually have to resize again right away. So now my table size is 8. Write in these values. And now I have to, before I add 15, I'm going to copy everything from my old array to my new array. Of course, I added 39 first and 63 second, but I don't know that at this point. All I know is that the order that I find them in the array. So I'm going to start at location 0 with 63, and I'm going to hash that first. The size of the table is 8, so 63 hash 8 is 7, or mod 8 is 7. So 63 goes in location 7. The next thing I find in my array is 39. 39 hash, or sorry, mod 8 is also 7. So I try to add it in location 7. That's not available, so I go to the next available location. That's location 0. And then I can add 15. So 15 mod 8 is also 7. So I try to add it in location 7. I can't. 63 is there. I try to add it in location 0. 39 is there. So finally I add it in location 1. And the rest of these are null. 5 null locations out of 8 possible, so that's good. The resize was successful. Now I'm going to remove 39. So this is actually fairly straightforward. If I went by the code, of course, I would first search for 39. And there would be some rules about, skipping over deletes and things like that, but we don't have any deletes. We only have nulls. So I look for 39. I hash it, but you don't have to do that. Basically, you're going to find it. You can just remove it and replace it with a delete or a D. Just make sure you try and write clearly. And that's it. Remove 39. The other thing you might want to consider is whether or not to resize. But if we go by the textbook, spoiler alert, you don't have to resize here, but it's worth taking a look at. So if 8 times the number of things that are in my table are less than the length of my table, then I'm going to resize, I'm going to shrink my table. N, the number of things in my table is 2. 8 times 2 is 16, and the length of my table is 8. So I'm saying, what did I do here? 3, 4, 5, 6, 7, yeah. If 8 times 2 is less than 8, then I'm going to resize. But of course, it's not less than 8. 16 is not less than 8, so I don't have to resize. So this is good for the remove. Okay. Finally, I'm going to add 47. So let me redraw this one more time. And let me check to make sure I'm getting this on video so that I don't have to do this again. I'd be happy to know that this is the 5th time I've tried to do this. And I always end up cutting off part of the video. So add 47. So 47, let's put everything back in the array first of all. Add 47, so I'm going to hash 47. 47 mod 8 is 7. Shocker. So I try to add it to location 7. 63 is there. I try to add it to location 0. Now, in the textbook and in the class example, first we look for 47, skipping over the delete until we find a null character. And then we add 47 at the first available location, so we add it at the delete location. You can see that 47 does not exist in this table, so you can, cut to the chase and simply add it in the delete square. So there, that's it. That is the full example. The one that you see on the final exam will look very similar to this. There will be some different numbers, but there will be 4 adds in total and 1 remove. And basically, you will be resizing up. Be very careful about that. You won't be resizing down. You won't have to do that. Okay, so I apologize for making that mistake. To try and make it up for you, I gave you more information about what will occur on the final exam, so hopefully that makes up for it. But sorry for the trouble anyway, and